yourself a quiz. Great. If you do have one, turn in as soon as you can. We've got a lot to do, so I think I'll just get moving then. Okay, here's where we are. So the rest of the notes are on speed tools. As you should have gotten a couple emails from me. The first one's probably kind of boring. Just giving you a reference to that when we talked about class in passing about how the appendix is part of the immune system. Just wanted to give a reference to that. Anytime any of you have something that you brought up in class, whatever you want to give a reference for, great. You can do that too. It's always a good idea. And so the new notes, I took down part 1, the empiricism handout, just put the whole thing up. You might want to just, when test time comes in a couple weeks, just get the whole handout again, because I have some, I did some rearranging in the first part. So there's no seats, huh?
What do you guys want my seats? I can show them.
Here's the chair. Wait. This is kind of strange. Hold on a minute. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 41. Yeah, that's what the roster is, 41. I'll see about switching rooms, but I don't know. I'll see about getting new chairs or something. Sorry about the every scaring you. I'm kidding. Okay, so let's get going with talking about more empiricism. See how these notes go. So a theory. Now, so we talked about empiricism a bit, and we'll talk about it a lot more. So let's talk about theory a little bit here. So a theory is an idea or set of ideas about something which is not at all empirical. Okay. It can be, the part that's not at all empirical would be the theoretical part. Okay. So, or only, you can have a theory that's approximately empirical but has theoretical aspects to it. If there's any part of a theory that involves something you can't see or perceive in some way, it's theoretical information. Okay? And so that means if somebody comes to you and says, I just discovered cold fusion, and you say, okay, show me the discovery. They say, well, I can't right now. I did it a little while ago, but I can't do it reproduce it right now for you. Then that means that the information to that person is empirical, if they're telling the truth, but to you, it's still theory, okay, because you can't see the results. Okay, so anyways, or only empirical. Okay, there's a typo here. Sorry about that. The Big Bang Theory is approximately empirical, and the theory of evolution is, at best, I would say, approximately empirical. Young Earth theory, so these are mainstream scientific views. This would be a view of certain people in certain religions, thinking the Earth is young. That would be a view that is only approximately empirical, at best. So if you can notice, a lot of big views that are held by religious groups or scientists may be only approximately empirical or hardly empirical at all. Okay. So we'll see that over and over this semester, and in these notes, that views that you're told are science or are empirical often aren't. And so we discussed this a little bit last class. We'll discuss, all this stuff more as we go. So empirical information is information we gain through our senses. This is different from, anybody know the quiz? Okay, good. This is different from a theory, which is a model of reality about a model or a hypothesis about something. So, for example, we are often told that in the mass media that the price of oil fluctuates because of changing weather conditions. Okay, anybody ever heard that? Maybe not. Yeah, it's gets mentioned in the news here and there. Here's a reference. Fortune magazine, got a blurb from a news story discussing that. So remember when oil skyrocketed a couple years, 4 or 5 years ago, to $150 a barrel, right, over just a few months? There was a lot of news stories out at that time suggesting or outrightly stating that weather conditions were responsible. Okay. Now that may be true. Okay. But it's, however, not an empirical claim to you. Okay, you're just told the information, and someone writing it presumes that you may believe it, but it is theoretical information, okay? Which, that's kind of in this case, that may be a big problem that it's theoretical information, because weather always changes and gets real cold. I mean, we very frequently have very cold. Last winter was very, very cold winter, okay? But I didn't see the price of oil doing that again. So we have a problem then. We have a theoretical problem and an empirical problem with this claim and this footnote here, and this claim which shows up in the news off of that weather conditions are responsible for prices of oil. We've got a lot of problems. First of all, I thought supply and demand was supposed to be responsible for the price of oil. At least that's what we're told in our economics classes. Very dubious information, however. Secondly, it's an empirical problem because we're not shown it, we're just told it, so it's actually a completely non-empirical claim. And theoretically, it's very problematical because we have inconsistencies, because why that particular season do we have the skyrocketing price where we didn't previously? So lots of problems with that. So theoretical information may or may not be directly based on what we can experience with our senses, and this is because theories are sets of ideas, and they are not reports about sets of sense experiences, okay? So a report, then, let me stick, so there's some error, there's some kind of careless writing in that. Okay, so this is an important issue in critical thinking, and something that we'll come back to on and off all semester. So a report is a statement or a set of statements used in critical thinking which do not form a conclusion. Okay, they don't. We'll find out what a conclusion is next week. But at the moment, you can just think of that as being when you have a set of ideas which don't take you anywhere. They just state things as they are. You know, here's a stack of papers. Okay. We don't say, here's a stack of papers, therefore I have to grade them or something, okay? A report just states things as you see them on the spot, okay? So they merely take down empirical details about some issue, reports do, and perceivable reality, which specifically is intended to be completely devoid of emotion. This is the most important part of this paragraph. Completely devoid of emotion, bias, opinion, or agenda. Okay, so report is the way we're using the word report in this class. And now, you know, some people use this word any different way. But here in this class, this semester, and right now, we're using it this way. So you can see that they're extremely rare anywhere in society, in science, in religion, anywhere. Hardly ever do people just merely report data that they perceive directly without any emotion, bias, opinion, or agenda. Okay, here's some examples of reports. A pen is a tool used to write with, okay? Notice how incredibly boring that is? Yeah. Reports are supposed to be extremely boring because they don't involve all this stuff, okay? You know, so anyway, we'll be counterexamples in a minute. Lawnmowers use gasoline. Okay, not all, but some do. Okay, doors are passageways to another world, just kidding. From one room to another. The hammer was found 6 feet from the murder victim. The lion devours the zebra carcass. Okay, so reports are very unexciting, all right? But this is where their power comes from. As you'll start to get a picture of that all semester of how powerful a report is, okay? And their unexcitement shows how they transcend the errors that come into play when language involves emotion, bias, opinion, or agenda, okay? As we'll see this semester as well, when these things enter into analysis of stuff, you know, some analysis you're doing or some account of something you're telling someone, errors very, very frequently enter into the picture, as you'll see. Okay, so when reports are expressed, often the people giving them will believe they are giving unbiased, unemotional, zero agenda information, but this is actually exceedingly rare, and usually when people believe they are giving them, they are in fact conveying accounts littered with emotion, bias, opinion, or agenda. Okay? So, anybody have any questions at this point? Kind of simple information. Okay, so a theoretical model. Now what we're doing here, I think we're just, okay, we've got 4, in this section, we've got 4 things we're going to go over. Report is the first, but well, three things, sorry. So a theoretical model, then, is very different from a report, and goes as follows. It's a model of reality or some aspect of reality, which is in part or in full based on some information that cannot be perceived with the senses currently. This does not mean in the future that it cannot. Okay? So that's kind of repeat. We just talked about that a second ago. So let's give some examples of theoretical models. Consciousness is physical. It is made up of parts of the brain. Okay? Psychology students? Anybody? Okay, 2, good, 3. Yeah, you probably hear this. I think you guys just did the other day. You said in your class. Really, any scientific field you're in, biology, neuroscience, psychology, anthropology. My undergrad degree is in anthropology, and this is what was first given this philosophy. Okay? Almost everybody in academia holds this to be the case. Consciousness is physical, meaning that it's some brain process of some sort. Okay? Nobody knows what. Now, the issue is, can any of you show me right now, somewhere or another, that this is the case? Okay, probably not. Some of you might say, well, if I have the encephalogram, how do I do a brain scan? And they say, think about your mother and this little part of my brain lights up. Sorry, somebody hands up. That may appear to you to be mapping consciousness as part of the brain. However, consciousness is not brain cells, okay, which is what you're seeing on the brain scan. Consciousness is your thoughts and feelings, which if you close your eyes, you can feel right now your feeling of extreme boredom, okay? So that feeling is what you don't pick up on the brain scan, okay? So consciousness has not ever been verified, not to this point at least. It could in the future, maybe. Yeah, who knows? But at the moment, this is a philosophy. It's a theoretical model, and scientists everywhere, literally, who claim that it's a part of science, are making an error, okay? It's a theory. It's a philosophy. It is not part of science, okay? Science involves stuff you can see. All right, so here's one other example. The Pyramid of the Sun, so remember, examples of theoretical models. The Pyramid of the Sun in central Mexico, and the Great Pyramid of Egypt, the one that has the cap off the top, are almost very nearly equal to one another in their base perimeter. They're not quite, they're a couple feet off. So these numbers are heavily related to some astronomical issues as well, so it's very likely that they share the same origin. Okay, heavily theoretical, right? Some of you probably think that this just is an outright false claim, I'm sure. I don't have any opinion that it's true or false. It was on the History Channel. That's why I think that's what that footnote is. That's why I put it in here. They find it interesting. But there's thousands of pyramids all over the world. Okay? Probably 2. Here's a counter argument to this. Probably 2 are going to have a similar perimeter. Okay? So to say that you don't have enough evidence in here to come to this conclusion here in this theoretical model. Okay? But then again, you don't have evidence to show that it's not. You just don't know. You don't have enough information to know either way. If you found 20 more pyramids tomorrow with right around that same perimeter, then things might get interesting, but 2 is not enough. All right? So, humans and, okay, next example of the theoretical model. Humans and bonobo chimpanzees have DNA coding that shares similarity to each other more than with any other creature, and this is because the 2 have similar structural, similar morphological features, similar structural features. They look, more like each other than any other creature in nature. Okay. So while that is extremely good reasoning, okay, and you can verify this part of it here, okay, that can be verified in the lab. All right. This, however, still involves some theory down here. Okay, why? Because what if a creature is found? What's the name of that? Let's say that monkey that was just found in Zaire, like a brother monkey or something it's called, or the bros monkey or something. I can't remember what it's called. They just found a scientist, and from England, just found a huge chimpanzee, 6-foot-tall chimpanzee in the rainforest of Africa, never discovered by Westerners before. Local people in the area already been talking about its existence, but Western scientists disagreed. They said, I'll believe when I see it, and it was found. So, why is this theoretical? Because what if we found a creature tomorrow that doesn't look very human, and somehow has similar DNA, more similar DNA patterns to us than bonobo chimpanzees? That could happen. It'd be very strange. Be a very strange creature as well. So the case, but there is a little bit of theory here. You can't verify every single creature in the world to be this way until you measure and know about every single creature. So theory, although this is very, very strong theory, with very little. Sorry, this is empirical and this is theoretical. It's very, it's coming right off the empirical evidence. So it's theoretical on a very minor degree. It still nevertheless is. Here's another one. So the way these examples are going is this one is an example that's everywhere. The theory that everybody academics all over the place use, I think, is empirical. The next one is a sloppy example. These next two are very, very sharp examples, which most people believe are strictly empirical, but which, however, are not. Okay, Cygnus X1 is a star system out in space. It's orbiting an invisible object where X-rays emit from the center of the region. Must be the Cygnus X1 orbits around a black hole. So, with our solar system, you got the sun, and then planets going around it. You can see the thing that the planets are going around. Cygnus X1, roughly, not exactly the case, but for cases of, if we're in a hurry and we just want to keep moving with our nose, it roughly looks like this. You don't see what's being orbited, okay? So, but it looks like it's orbiting something. You can't see it, and X-rays are coming out of there. That is a feature of black holes, it's believed, theoretically. This is very, very strong theory, but nevertheless, it's not fully empirical, okay? So the point is here is that a lot of theories that people use are real close to empirical, but are not quite there. To be fully empirical is a special case and is not extremely common, even in mainstream science, okay? Anybody have any questions? Okay, so an empirical model then is a model of reality, or some aspects of reality, which comes from, and do not in any way go beyond simpler basic sense experiences, which we'll talk about down in these notes a little bit what this means. Simple basic sense experiences one has about the world. These are very rare in culture, any kind of culture. Notice it doesn't say very rare in mainstream culture or something. No, all over the place. In science labs, churches, anywhere. It's very rare that people develop or use or refer to models that are perfectly empirical. Okay, they're out there. We'll go over tons of them this semester. But usually, models have some theory that come into them. So they will often sound very much like a report. And okay, so here's some examples. Here we go. Right here. We were just talking about this. This you'll find interesting. Heart transplant patients, also bone marrow transplant patients, so this have that written up here. Heart transplant patients often report having new memories and conscious elements right after the procedure, starting right after the procedure. Okay? Okay, so which were not present, so have new memories, and you know when you close your eyes and all of a sudden you have like a picture of Oprah Winfrey flying across your mental screen or whatever, something flies across your mental picture that you have that's always present in your head. You'll have new images that feel like memories. Okay, you have new desires. Oh, I like French fries now. Why do I like French fries? I always hated them before. Now I just want to eat them all day and all night. So you'll have new memories and conscious elements starting right after the procedure will emerge, which were not present before, and which can be traced to be from the organ donor. Also, hearts have dopamine, a neurotransmitter. What's that doing in the heart? Okay? Associated with consciousness. So therefore, hearts have consciousness to some degree in them. So is this empirical? You tell me. I thought it was. Is there any theory anywhere? Is there theory here?
say that consciousness, but they have something like consciousness.
Well, okay, so a memory, maybe you're right, but it seems like a memory would be an element of consciousness. Because if not, then you'd have to assert that there's things that can have memories but aren't conscious. But maybe you have, okay, do you think a lion is conscious?
Well, yeah.
Okay, so then you're, okay, if you said no, then actually you'd
No.
be consistent. But, well, okay, so, well, then you would be stuck having to explain how there can be things that have consciousness, where there can be memories without consciousness. Maybe that can happen, I don't know, but that would be kind of a strange scenario.
Dopamine just triggers a feeling, doesn't it?
I don't know.
Oh.
I mean, I don't know all the things, I mean, I don't know, that's part of it. I mean, I just don't know the whole story.
Because it's just a chemical. I don't think a chemical carries memory.
Yeah, there's like 1,000 neurotransmitters. It's just one that's focused on so much because that's what big pharma, with all the antidepressants, is focused on.
I mean, if it has a big concentration of dopamine, when you pop it in your stomach or whatever the heart goes, you know what I mean? If that triggers an old memory that you've forgotten and brings it back, maybe it's just your memory is just gone.
Yeah, okay. So you think this might have some theory built into it?
Yeah.
Okay. You know, I put it there because, you know, I could see that it looks empirical, but it could, you know, there could be theory that we don't even know we've interjected into this. So, heart transplant places reporting memories, that, you know, what's empirical there? Somebody's telling you a story. I have these new memories, okay? What's empirical is that this person's telling you that, okay? So they're telling you they weren't present before. They can be traced to the previous donors. You can find out, go talk to the family members. Oh yeah, they ate French fries all the time. You can measure this. Their hearts have dopamine. And apparently, a little bit in disagreement with what you're saying, you can find that anytime. Not just after you take a dopamine pill or something.
Oh, yeah.
So therefore, this is where the theory would come in, it seems, if it is there. Hearts may have consciousness to some degree in them. I don't know, it sounds perfectly empirical to me, but I wouldn't be surprised if there was an error where there's some theory right here. You know, what does this mean?
Yeah.
You know, is the thing I'm doing up here in my head, if that's what consciousness is, well then my heart doesn't have that fully, it seems like, you know. So that's kind of an interesting one. It seems like it's perfectly empirical, but notice how I'm saying I don't know and could be borderline. That's how the whole semester will be like that, okay? This is we'll see a funny quote later in these notes, not from one of our textbooks, but from another critical thinking book, which says that critical thinking is a mess, okay? And so all of you who want a nice, just drop it after you're still doing that, all of you who want a nice cut and dry class, memorize your table and reproduce it on the test. This is the opposite of that kind of class. This class is, well, kind of what you've seen demonstrated so far. It's an exploration, and we don't have any idea where we're going. Okay, so anyway, here's another one that might be perfectly empirical. My husband has been home so so often lately, uninterested in sex, and often seeming to want to get off the phone quickly when I walk in on him unexpectedly while he's on the phone, which is more than usual. I don't have any proof he's having an affair, but these issues could be symptoms. No conclusion is drawn. This is a report. He's home late, doesn't want to, he's on the phone, that's a report. Doesn't it sound like a report? Doesn't it sound kind of like, these are papers, right, yawn? I think what this footnote says here is, it could be that he's doing secret illegal business transactions or something, he's all stressed out, lowering the, what did Austin Powers call it? Mojo, or something. So, that one, anybody disagree? I mean, there could be theory, but it sounds to me perfectly empirical, unless she's lying or something, assuming this is a lady saying this. Okay, here's another one that appears to be perfectly empirical. Particle A and particle B exhibit spin reversal. Okay, particles are what we're referring to here. Remember we talked earlier in the last class, about how reality is made of little basic building blocks, little pieces of irreducible energy. That's what we're referring to here when we say particle. Okay, just like your Tinker Toy set's made of little irreducible pieces, reality is as well. Okay, they're called energy points or quantum particles. So particle A and particle B exhibit spin reversal at a distance. I'll explain what that means in a second. And those exhibit quantum entanglement. Okay, what this is, quantum entanglement is one of the more shocking discoveries in science in the past. Well, really it was kind of discovered with mathematics theory in the early, like 1917 or something, by a member of the French royalty.
Electron rotation.
And but that was confirmed in the lab in 1970 by a guy named Aspect. What it is the following. So if you take one of these building blocks, one of these particles that makes up reality, call it A. And you got another one over here, call it B. Okay, it doesn't matter how far they could be a micro-inch away from each other, or a light year, from here to the sun or something, or much further, light years apart. It doesn't matter their distance. What happens is if you have, this one is spinning in this direction, and this one is spinning in this direction, if they share this relationship with each other, which is called entanglement, if you take this one in the lab and change its spin to be the opposite, this one that's in a entanglement relationship with will instantly change its spin as well. Notice the word I used there is instantly. Okay? Who does that violate? Appear to violate? Einstein. Nothing can travel faster than the speed of light. This is instant. This is, there isn't some, communication where, which was sent back and forth. Right away. Okay, as this one does it, this one does it. Okay? That has been confirmed in the lab, and you can confirm it in the lab anytime you want. Okay? So the issue is here, that sounds like a perfectly empirical, unemotional statement.
Yeah, so I'm kind of confused. Does that mean if you switch the rotation of one particle, does that mean every rotation of every particle?
If they're in this relationship.
They're in that.
Some theorize that all particles are because of the Big Bang, but that is not confirmed experimentally.
How do they prove that they're all entangled?
Well, what you do is if you make particle A and B interact, these basic building blocks, interact means they kind of merge and become one and then separate out again. It's not really clear what it means when they touch or whatever. Then they'll be in an entanglement relationship.
Okay.
And then you can do these operations.
And you can separate them.
As far as you want. Light years.
So did they put them on opposite ends there and then switch them?
Yeah, opposite ends of a particle accelerator, you do two in different particles. Oh wait, I don't know enough about it, but I know in the particle accelerator you do on opposite sides and stuff. Yeah, it's very bizarre. There's a lot of you probably heard in the news. There's a lot of questioning about is the speed of light. Did we get it right? Is it constant or does it change? That just a few years ago would have been, you would have lost your PhD or license to do science for just saying that. Now all of a sudden, it's mainstream. So that's how quick ideas can change. We've got a whole section here in a minute about how, changing your ideas and stuff. Oh, it's the next section. Any other questions or anything? Okay, science is in motion. Okay, this class is largely about science. Okay? Not about scientific issues, but about how to think like a scientist. And you'll find out quickly that the procedures you learn in this class, and if you start practicing them, you will actually think more sharply than the average scientist you go and talk to. Okay? That includes economists, anthropologists, psychologists, and so forth. So, you'll see that as we go through the semester. Now, science is not static. Static means staying still. Okay? That means that there might not be any facts, okay, in science. I'm not sure that, that's possible. Let me explain what I mean more. Science is in motion. It means it changes constantly, okay? So that means what one group thought was a fact in one time, in the future, will be overturned and not believed to be a fact. So the whole concept of facts this semester will not be a huge priority. It's not like we're going to try to figure out what facts are. We're going to kind of go the opposite direction and sort of assert that we never really know what these are for these reasons that you're going to learn in this section and then in a whole chapter later this semester after 5 of the Weird Things book. So, okay, here we go. Theories about reality, whether they are based on observation or not, if they're empirical or theoretical, are destined to be modified or replaced by new, better theories. Okay?
Until they become a block, like, how they're saying the world is flat, and then it's like, whoa.
Yeah, that's in these notes in a minute. But, a law, there's very few things that are called a scientific law. When you develop a hypothesis, make it a working hypothesis, then when does it become a law? Actually, philosophers fight about that. You know, what does that mean? Some like me say it never becomes a law. People who say it's a law are making a mistake. It used to be that light, there's a law of nature that its speed was 186,000 miles per second. Oops. You know, now everybody's questioning that. So that's why people like me don't introduce laws. But other people do. You know, so we'll talk about that more as we go. So let me give some examples of this idea that theories about reality appear to always be replaced by new information. Okay? Here, I got a whole bunch of examples. Newton, everybody heard of him, Isaac Newton? Probably one of the most influential people in history, Western history. Western means, you know, Europe, America, Canada, and stuff. Newton gave us the theory of gravity, which was believed by so many for 300 years to be fully correct. Oops. Okay. But then it was found to have problems. Okay. What people started finding things that didn't match up to. So what his theory did was describe how objects move around. If you shoot a cannonball from one ship to the other in a war, you want to be able to figure out exactly the trajectory of the cannonball from one boat to the other. Here's a boat. Here's a boat. And if you can do that, you've got a big advantage in a war. Okay? So that's what some of Newton's work could do, for example. But then it was found that it didn't apply to many things, such as things going at a high rate of speed, like the planet Mercury around the sun. And then Einstein came along and literally turned Newton's work to a large degree on its head, so to speak. All right? So look at this. The point here is people believed it was gospel truth for 300 years. And all it took was a couple observations. Now, everybody in professional science appears to agree that it's just an approximate model, which just works for situations here on Earth. And that's about it. Now, interestingly, as an aside here, gravity still is based on Newton's work. Okay, now we found a lot of problems with it, especially out in space. Now, interestingly, astronomers, go talk to your astronomy professor, your physics professor, and ask them about dark matter. Everybody's heard of that, right? Yeah, everybody's heard of it. So there's all kinds of huge, did I say huge, problems with gravity. Everybody knows what gravity is, right? See? Tendency for objects with mass to move towards each other. The more mass, the more energetic the moving. Okay, so the more momentum the moving has. So, what was I going to say? So there's all kinds. If you take Newton's gravity and apply it to the universe or galaxies, which are just big collections of stars, is what a galaxy is, you find huge, massive problems. So big that scientists have theorized that when we look at a galaxy, you know, it looks kind of like this. You know, here's where something like that. The lines are within the chalk where the stars are. You know, it could be like 100,000 light years across or something. That's how long it takes light to travel 100,000 years, which is really, really big and far. You find out that, scientists are saying that our theories of gravity make so little sense that we have to assert that up to 5 times more stuff is there that we can't see, which is called dark matter. Okay? My prediction is, in the coming years, we'll find out that that's wrong, and this just needs to be modified. Okay, there's all kinds of evidence for that. We'll try to talk about that later this semester. Any questions? Okay, good. Well, let me keep going here. So Newton was overturned by Einstein. Now, quantum physics is severely challenging, is an understatement, the work of Einstein. Okay? Right here. Wow. This deal with particles interacting instantaneously, that's a very specific violation of Einstein's work. Okay? Because Einstein said everything has to operate according to cause and effect. What's cause and effect? It looks like this. The cause of something will be me dropping the chalk. The effect will be you hear something. See? Cause, effect. That's a philosophy of nature, where all the events in nature follow each other in a rhythm, and they produce each other, so to speak. One event produces another. Okay, now this quantum entanglement does not involve that when particles are linked that way, because they have instant interaction. Cause and effect requires there to be a time separation. First the cause happens, second the effect happens, but that doesn't happen here. So Einstein is and this is experimentally verified, and Einstein's work here was just theory. So big problems for Einstein's work. You won't hear that on the Discovery Channel. Now, when we have a quiz next time, by the way, so obviously be able to these notes we're going over. You're not going to get a question like this. What is quantum entanglement? Okay. No, you get a question like, why is science not static? There's always big, broad questions. Never get nitpicky questions. Okay. How many years did people believe Einstein or Newton's theory to be gospel truth? That's 300 approximation anyway. So just relax, enjoy. The point of the semester is to try to enjoy it. I know this isn't as fun as munching popcorn at a movie or something. But the point is to enjoy yourself as much as possible. So don't worry. Okay, everything will be real basic like the first quiz that all of you just ate, right? Hopefully. I'm sure everybody did. The first quiz is always have a couple people who are figuring out the system. Okay, so let's move on here. Plate tectonics replaced expanding Earth theory. That's what Nick brought up last class. Reproduction theory replaced abiogenesis. Everybody know what that is? The frogs come from mud? No, frogs come from other frogs. Okay, so reproduction theory. Gravity replaced angels' wings theory. Used to be believed by some in the Middle Ages that the planets were held in place because the angels were batting all that wind to keep the planets just in their places. Nope, gravity replaced that. Currently, homeopathy, this is interesting, appears to be replacing orthodox medicine at least partially. And it's too early, we'll see what happens. Maybe that's temporary, maybe a little more. Like where I live in Ann Arbor, my baby boy just got sick, and we took him to a medical doctor, MD, who was an expert in homeopathy, and he prescribed a flower, little pellets that I looked up on the internet. There's made of a little flower called I forgot, Polyceta or something. That's a big deal. You've got a whole different kind of, and there's just a gajillion people interested in this. So it's a serious issue where it appears to be replacing orthodox medicine. Go to, go to Walt Slave Mart or whatever, and you'll see a huge vitamin aisle. It takes up a significant part of the store. That's what we're talking about. Yeah.
My mom is like a big believer in that stuff, and I still believe in pop and hope, and we go back and forth all the time, and she had a month in her breast with she thought it was breast cancer, but she took the medicine, and she 2 years later didn't have anything there, and she's a big believer now of those drugs.
See, both of them, orthodox and homeopathic medicine, both have big successes. Yeah. So it's hard to tell, is one better than the other? Should they be, complement each other or work together? It's hard to tell what's going on. I mean, chemotherapy, works half the time or something. I guess. And then medical marijuana supposedly works a lot more, really well at curing cancer. So.
Well, there was a Harvard study that Blake just read me it because we were doing work for one of our corporate responsibility classes. And he just read to me that
corporate responsibility was in the class.
Yeah, corporate responsibility.
Okay.
Anyway, we had a Harvard study, and it just basically proved that smoking weed has no long-term effects on anybody.
Yeah, actually, ironically, there's some medical marijuana stuff in these notes, so I came armed. Here's Science of Marijuana, Oxford University Press, most prestigious academic publisher in the world. This book claims the same. It's no memory problem.
Moderate white though.
Pardon?
Moderate.
This book would disagree with you. This book would say smoke all day, every day, be stoned 24 hours a day for 50 years, and nothing will happen. That's what amazing they do, and check it out. This could be wrong. One book does not settle an issue. 50 books and people fighting may. But, you want to check it out? Whatever. If you want, email me, I'll need the citation page, whatever you want. Let's just move on. So interesting stuff though. Okay, so moving on here. Again, let me say, this may or may, there's no side being taken, at least not by me, here. For, against, whatever. Just noting an observation that this appears to be happening. Homeopathy seems to be really moving in the medical field to a big way. So, okay, Big Bang Theory replaced steady-state universe theory. Okay, the Big Bang Theory is the idea that the universe is expanding. Okay, steady-state universe is the idea that it isn't. Okay, this was replaced because there's pretty good empirical evidence that something like this expansion is happening. Okay, so particle exchange theory is Darwinism replaced Lamarckianism, punctuated equilibrium, we discussed last time, is still in the process of replacing Darwinism. Flat Earth theory was replaced by spiritualist theory. Heliocentrism, sun-centered solar system theory, replaced Earth-centered solar system theory. Subatomic theory replaced atom theory. Here's a more everyday example. Americans are all told about global warming. Everybody's talking about it again because we've got a warm January. It's been around for 25 years, but now many are questioning that theory because they're not seeing it enough. This month you are. So people seem to. I actually do a little. My father and mother would just ask me, so what do you think about global warming, Dad? And he's like, well, I don't know. If I would ask him the same question a month earlier, it's just a bunch of crap, because he'll just, on his perceptions, he'll change his mind real quick, which I guess is fine, but seems a little bit imprecise. So now many are questioning this. In the 1970s, the mass media, it's just as heavily as they're pushing global warming theory, pushed global cooling theory, impending ice age theory. But it never panned out in any way. Just as global warming doesn't seem to be. Maybe it will. Maybe it's right. Maybe we're going to get cooked like Al Gore tells us. But who knows? It's too early to tell maybe. But some are growing a little bit skeptical. And anyway, but now there's a lot of talk about climate change theory, which is very strange because climate's always changed. 10,000 years ago, the Sahara Desert was swampy type place. So to try to fight climate change is like trying to stop the wind or something. That's supposed to be funny. Nobody's laughing. Think that's funny? I think it's funny. Stop the wind. I could get, politicians up there. We've got a serious problem with the wind. It blew signs over the highway. We need to stop the wind. It's a very big social problem. So, anyways, the point here is though that you've got three shifts. You've got global cooling, global warming, climate change now seems to be, and is there any evidence for any of them? I don't know. We're told there is by people that have bad reputations for not telling the truth on certain things, mass media, that is. So I don't know if it's true or false. But the point is that ideas are replacing. Okay, so, any questions? Okay, so there are an incredible amount of examples because science changes. Work in science is replaced by new theories due to new empirical information that arises and prompts scientists to replace one theory with another, or because scientists merely prefer one theory over another. You catch that? That is the case with expanding Earth theory being replaced by plate tectonics. There wasn't real clear evidence. It was just one theory was preferred by scientists over the other. Fine, I think it's a little sloppy, but hey, whatever. They can do whatever they want. Heliocentrism, sun-centered solar system theory, was replaced by sun-centered solar system theory replaced Earth-centered solar system theory about 160 years ago. Guess how much evidence existed for that? Zero. It was just a preference. Okay?
Wasn't that math stuff?
Parallax?
Yeah.
Mm-hmm. Parallax could sell the issue. But it's, to my knowledge, I think this is what this footnote says here. If you read back in the 1800s, it'll say parallax settled it. And then you look a little bit further, and you see that they never really were sure. So those angles are incredibly, it's impossible to do those with that equipment. You could do it now, though. But as far as I know, nobody's doing it. Everybody just is going with it. There's more important things to do. Find the asteroid that's going to hit Earth or something with your telescope rather than verify that the sun doesn't start in the solar system. What a moron, It's probably what, somebody's probably too afraid to even do that. But to my knowledge, and this is, if you go read a modern textbook in astronomy, they will say, and you can go ask your astronomy professor, most will say that this was parallax never really settled the issue. But it could today, because Hubble or something could, 2 seconds could figure it out, but I don't think anybody's done it. So that would be, it appears to be a preference theory. So, because when you look up in the sky, both what you see in the sky is explained by 2 theories perfectly. Okay, that's very common. But the theories are different, but they explain the motions of the planets and so forth perfectly. Both of them do. So, very interesting. Any other questions? Okay, the old theory is comical and the new one is correct. Okay. Interestingly, often the old theories, they get replaced, following what we just said about the last. This is what people do. It's not only scientists that do this. Expanding Earth replaced plate tectonics, now everybody thinks expanding Earth is a dumb theory. You all do this in your daily life, okay? You maybe believe that, there was reason to go to war in 2003, and then you change your mind later and can't believe how dumb of an idea it was, when you look back on it. I'm not saying that it was, I'm saying you may think that. Okay, I'm talking about Iraq. So this idea of ideas replacing each other is, in the modern world, it happens everywhere in all levels of society. Let's read through it here. Interestingly, often the old theories that get replaced are laughed at because people find them funny. Interesting that happens. And can't believe anybody holds such stupid theories. Okay? How can anybody believe the Earth is flat? Well, is it that stupid? I drove here from Ann Arbor and the Earth looks flat to me. I didn't feel like I was going around a circle, or a sphere, that is. So, when I was a kid, everybody told me the Earth was round. I'm like, I don't really believe you, because why don't I fall off or something then? So, anyway, so this means that since when the theories get replaced, you have this immediate reaction after, how dumb the old theory was. So this means that theories that are held today will one day be laughed at, most likely. Isn't that interesting? All the theories, if we trace every single idea out there that, say a major idea in a university, we can trace them to be a progression of other ideas leading to that point, and where the other ideas that led to the current idea are considered often silly and stupid. So that would seem to mean that, since that's happened every other time, that the current ideas, at some point, 5 years from now, 100 years from now, the same will happen and new ideas will replace them. Do you have something?
I was thinking of the quote the former CEO for IBM said in 1960s. I think there's no way anybody would buy a computer. There would never be a need for any of this stuff.
Yeah.
I think the market took off literally for computers.
Yeah, I've heard that quote too. And then the guy bullying George Boole, the guy who invented bullying, didn't he kind of lose his mind or something, developing all that algebra and everything? You're ruining your career with stupid math you're creating, and then I think it was after he died, they're like, hey, we can use this for the computer. So that's very good, very good. So it's very profound issues here. Why is this profound? Because that means when you go to your psychology classes, when you go to your economics classes, your business classes, physics classes, wherever you go to, your professor may not like this, you may want to keep quiet about it, but you should have this in your mind. Why? Because then you won't just believe everything that she or he says. Okay? This makes you skeptical. And when you're skeptical, you don't just believe things. When we don't just believe things, you tend to notice errors. Okay? When everybody was ready to go to war in 2003, nobody was being skeptical. Well, the huge mass population, as far as I can tell, wasn't skeptical. When you have that tunnel vision, you can't notice, you're not self-reflective, you're not noticing your errors. That's what this is all about. Okay? Whether it's going to war or believing what your physics professor says, the tunnel vision, believing that you've got the right idea is a problem for these reasons. You probably never have the right idea in your mind. If you believe in God, your idea of God will change. 5 years, you'll think something probably quite different. It'll change through your whole life, and maybe you got more and more correct as you went through life. Maybe it didn't. Who knows? You'll have to figure it out for yourself. So it's not just science, it's religion as well. Okay? So often people laugh at the theories they used to hold, which they have replaced in their minds. For example, people who are atheists often are shocked to believe, or shocked that they ever believed in God. It's kind of a funny example, right? When I was an atheist, I was like, how on earth, or on heaven or whatever, could I ever believe in such a stupid idea? That's when I was atheist, I just couldn't believe it. Here's another example. Anybody a conspiracy theorist? I'm kind of. As far as scientific issues, I'm kind of one. If you're a conspiracy theorist, you often can't believe you used to hold the old ideas that you did, and which were replaced by your conspiracy ideas. Okay? So, everybody know what a conspiracy theory is? it'll come up sometimes in discussion. It's kind of the idea, it's like X-Files ideas, where you believe that, the world powers that are in place, the government stuff, aren't the real powers, there's like a secret power behind them. Whether it's a secret group of people, or aliens, or something. Yes?
Would an example be like, did anyone really go to the moon?
Yeah, then you've got all the little theories in conspiracy theory. So if you've got a secret government rather than a real one, well then what else are they lying to us? Is the moon landing fake? Somebody brought that up. This exact same point last semester when I went over this exact same idea. Somebody brought up the exact same thing. Yeah.
Can Illuminati fly that?
Yeah. And then you can do the same thing. Are you empirical? Are they theoretical? You got to go through your, because a lot of the conspiracy theory ideas will check out empirically or won't, just like scientific ideas, same way. So yeah, but the point is here is that this is one of the more shocking shifts a person can have. When somebody is converts to conspiracy theory, it's a huge shift. They'll often throw away all their old ideas and search for new ideas. So it's really very productive. Whenever you do that, it's kind of a scientific process. Because as Karl Popper, a philosopher we're going to study all semester, he's like the critical thinking dude in philosophy. He said that that's what you're supposed to be doing. If you have, static ideas that don't change, you're not practicing scientific thought. Well, you need to have your ideas being replaced by new and better information. So, in all cases, the new theory that an individual, culture, group scientist, or whatever adopts will be believed with incredible confidence to be the correct theory, and the old one to be a joke. Okay? Isn't that interesting? Okay, people will do this in their lifetime. Oh, I loved Hitler in 1938. Oops, in 1948. But people, interestingly, no matter who you are, if you're a minister, if you're a scientist, politician, or just Joe who works at 7-Eleven. I used to work at 7-Eleven. Did I tell you that already? Yeah, the police story, right, yeah. So, like the police and, yeah. People don't seem to pick up that they're doing this. Hey, I was wrong those other times, changed my mind, was wrong again, so maybe right now I'm wrong. People don't do that very often, which is, I don't know, it seems that we should, okay? And, people are sitting here fighting that, with each other over ideas that in 5 years they may change their mind on. It's better to, in this class, you'll learn to hold a view where you follow evidence rather than conclusions. You'll see what that means in the next set of notes. Any questions? Really? Yeah.
Do you think that people's fear of being wrong and of doubt is in some way a way of them acknowledging that they're not, in fact, like human, or they're not, in fact, able to be outwilled or outsmarted by their human counterparts?
Yeah. It could be just as simple as, people don't want to be laughed at, you don't want to be wrong. And also, with me personally,
pride thing that humans have, like a pride thing that we as humans have.
Mm-hmm. Yeah, sure, absolutely. It could be that and other things. I know that what you just said happens with some people. With me personally, I've got a gene or something where I just have to know stuff. I want as much information as possible. I want stuff like real information. It's wired into me or something. And so there's another people there's people like that, So you want to believe when you get to a new theory, oh, finally I've got real information, then 5 years later, oops, so it can be discouraging. Any other questions? Okay, so theory, let's talk about theories a little more. So up to this point in this handout, you may start to get the idea that theory making can be very fluid and or problematical. Does this mean that theory is absolutely detestable? No, of course not. Both theory and empirical, both theoretical models and empirical models, both have serious problems with them. It just seems like empirical models work a little better, as we're discussing in this handout. So theory making can be dangerous and detestable, but usually only when it is not under the guidance of adept critical thinking, as is the case in American culture, yeah. So in other words, if you develop theory or use theory with critical thinking, it could be a good tool to use. If you don't, well, then you've got what you see in America today, which is a huge mess. Everybody just believes any theory that, oh, I heard on Fox News and that, or MSNBC that blah, blah, blah is the case. So, and then people just believe it. Now, that's the epitome of uncritical thinking. Okay, that's, just believing whatever it tells you. Yeah.
Does that go with a lot of those, like, new religions, kind of like how
Sure.
Madonna was doing the science,
Yeah.
whatever,
Travolta.
like, you can hear about it now, and then I guess something new is out now, so it's just like this fluctuation or this following.
Yeah, it happens at every level. It can happen in a science department here at U of M, or it can happen in a cult or with a Hollywood, anywhere. Whenever you have people following theories uncritically, which is all you need to do to see that happening, is just think about your world. Because this is the definition of what everybody in our culture does, routinely, with no problem. You'll see it this semester that it's an absolute disaster if people do that. So yeah, but there's no special place. There's no church that has the right information, as far as we can tell. There's no special science department that we can find. No, all we know is that everybody's, kind of like feeling their way around in the dark, to find the right information about reality. And the best tool we'll find out this semester is that. And you can get good info by using critical thinking. Okay? Anybody else have any questions? Okay, so we will address these issues about theories and theory making all semester. But you should note that theories are good when they're guided by critical thinking, and bad when they are guided by propaganda, rumor, hearsay, conjecture, and they're usually harmful, or even most harmful when they are devoid of empirical analysis. Okay, I just repeat what I just said a second ago. Adding to this point, note that the most empirical work in science, even the most strictly founded work, will result in theory. Okay, did you hear that? And that may not be a bad thing. Again, knowing what we just said, if all the techniques about critical thinking you're going to learn about this semester are used in building a theory, that's probably, you're probably not in danger of developing some completely insane theory, which is radically wrong. Okay, we'll find out we'll see examples of that all semester. So, for example, the examples given above about bonobos, chimpanzees, and Cygnus X1 are very strictly empirical, but nevertheless, they involve some theory. Also, our illustration about the green leaf. Okay, so now let's go over an example of where empirical observations can be shown to be wrong. Okay, remember we talked about the leaf is not actually green. Remember? I covered that, right? Yeah. Thank you. That means that your empirical experience of a leaf. Is there a leaf anywhere? No, it's January. When you see one, you were seeing something that doesn't exist. So your empirical experience right there is wrong. Okay, so do you see how? Yeah. So now that empirical idea. Now you might think when you're looking at a green leaf, you might say, "I can't be wrong. It's green. I can see it right there in front of my face. It is green." Guess what? That is a theory. Okay, why? Because you're only looking at the leaf from one perspective, one angle, what's called the macroscopic perspective. That's a word we're going to use all semester. Okay? Everybody knows what microscopic means, right? Teeny. Macroscopic means this view of things. The view that you view the world with without the aid of a telescope to see huge stuff out way far away, or teeny stuff right in front of you. Okay? I don't know what the big one is called, cosmoscopic or something? I don't know. If you say that the leaf is green, believe it or not, there's theory there. Because you're not entertaining the idea that it's possible there could be another way of looking at the leaf which wouldn't show it to be green. Okay? So some empirical observations, which seem to be perfect empirical observations, often will have theory built right into them. Okay? So the theory built into the leaf statement is the idea that this view right here is a view that gives me perfect knowledge, looking at the leaf in my hand of the leaf, and it shows me truth, shows me the way reality is. There's your theory right there. Okay? Now, what you should say is, it seems to me that the leaf is perfectly green. It seems that I've got perfect and raw empirical observation, but I'm not sure. What if I could break it down or look at it some other way? Would it show that I'm in error? That's the view you should hold. Okay? The skeptical view. Critical thinking is not about drawing truth. Okay? And in this class, we'll probably say, if truth is out there, great, but we'll never find it in this university, we'll never find it in this class this semester, and so forth. Okay, so, blah, blah, blah. All right, so let's go, yeah, this is a good section here. From this point, okay, there's 4 types of information we're going to be concerned with this semester. Okay? So from this point, what I call theories, well, let's just go through them right here. So the first type of information we're concerned with are raw empirical data, or what we'll call direct perceptions. That green leaf would be one. Okay? And this is a report that involves, or at least attempts to involve attempts to involve zero theory. I'm in a room right now. That seems to be, I can't break that down any further. It seems, I mean, maybe I could, but it seems to be very, very safe to be, it's only based on pure perception, or, sorry, direct perception, okay? Clouds exist in the sky. Boom, see? It's kind of a similar idea as I'm in a room right now. You just have a raw observation and there's nothing, no ideas added into it. Humans use language, same idea. These are hard to come by, these are hard to come to, since it's hard to find statements that don't involve little bits of theory. Okay, so this is rare that we find these in culture. If you're a news reporter, this is what you're supposed to be using. Okay, but of course we all know that doesn't quite always happen. So again, these are like reports that we talked about in the notes. Questions? Okay. Empirical theory. These are, or before you can call empirically based simple theories. We'll just call them empirical theories this semester. These are theories that get their distance from going, if you take this right here and add a teeny bit of the safest theory, like we did with Cygnus X1 or the bonobos, then you have an empirical theory. Okay? Quantum particles don't have size. There's another one. We'll talk about that more this semester if you want to know more. Okay, here's another one. Mainstream science. So remember, these are all on C-tools and stuff. All these notes, of course. So mainstream science, or what are called loosely empirical theories. Okay, this is different from empirical theories that we just discussed. Okay, now we're calling them loosely empirical theories. That means there's a lot of theory. There'll be theories and models based on empirical ideas, but lots of theory is involved in them. Now notice that's what we're classifying mainstream science. What's mainstream science? It's the science that everybody's concerned with. Plate tectonics, Big Bang theory. Somebody give me a psychology theory. Anyway?
Consciousness?
Well.
Behaviorism.
Yeah, there we go. Good, yeah, very good. Behaviorism. Yeah, that's a really good one. Good example. So, unfortunately, mainstream science is typically not nearly as careful about things as it should be. What we are calling loosely empirical theories are similar to the spotlighted theories of mainstream science. Whoops, sorry. All right. What we're calling loosely empirical theories are similar to the spotlighted theories of mainstream science. Yeah, okay. These are theories that are not empirical because if they involve elements of theory, then the whole theory is not an empirical theory. Okay? So the only reports are like that. Alright? So they, however, follow empirical analysis much more loosely than empirical techniques just described in the previous one, with empirical theories. Raw empirical data and so since they sorry, the only should be there. I was editing these for the last few days, so there's some remnants of that. So since they are loosely empirical, oh, that worked, didn't it? No, it's not a typo, sorry. Since they are only loosely, maybe I should read the sentence first. Huh? Maybe since they follow, that's the typo, okay, sorry. Right there. since they are only loosely empirical, meaning there's a surprisingly small amount of empirical data, report type stuff, supporting them, it seems inappropriate to call them empirical theories. They should be called loosely empirical theories, or mainstream science, okay? So, here we go. Now notice, these are your science professors may or may not agree with what was just said here. Because your science professors, this is where they fall in this class here. So what we're doing, we're saying they're not strict empiricists, they're only loosely associated, or loosely called empiricists. And here's some examples. The Big Bang comes from a singularity. Well, that's just the basis of most of the ideas about the Big Bang. Has anybody ever seen it? Of course not. Okay? You can't see back that far. Well, there's a lot of reasons why you can't. Okay? So that is theory. Theory to the core. That's not even really empirical at all. Okay? So here we go. Mid-Atlantic ridges, mountain valleys, and mineral placement on Earth shows continents are drifting. Any geology students in here? Theory. Okay? Has anybody seen a continent move? Okay? No. What will happen is you get your geology professor will say, hey, Stevie, there's some mountains here and some mountains here. See, they're moving apart. See this valley? They're moving apart. And you'll say, I see stillness. I don't see motion. So literally, it gets kind of strange a little bit when you get non-empirical. But amazingly, this same stuff can all be described by what's called expanding Earth theory. It's got 1 minute. So the heat from the sun comes from the sun's core rather than the corona, that part of it that's not even on the sun, but it's really ultra hot. Okay, is this empirical or theoretical? Anybody seen the inside of the sun lately? Anybody traveled in there? No. Okay. These are heavily theoretical. Okay. We're calling them loosely empirical, but we're being a little bit generous. This is an idea based on something invisible. Invisible because you can't see it. Okay. Oh, it's sad. We ran out of time. Okay, so we'll start right there. Next class, so from the Calvin and Hobbes comics to right here is anywhere in those there. You'll get some broad questions for your quiz question.